Now this time, let's try to identify the number of derangements without listing them systematically for 3 permutations of N4. Now we are going to solve the number of derangements by first identifying the number of permutations with specific fixed point. So that's why it's called different sets here. I'm going to illustrate all of them for this video. Take note that our N4 has elements 1, 2, 3, and 4. So that means the cardinality of that, N4, that's 4, is actually 4. That would be our N later on in the formula. So to solve for the derangements, again, let's try to first identify the number of permutations that can be made considering number of fixed points. That would mean we'll be using this formula, N, R, K. We'll have here the R combination K over N minus R factorial times the summation of -1 raised to I, R minus K, combination I, N minus K minus I factorial, where I starts from 0 to R minus K. Okay? So, say for example, you would like to identify the number of derangements, meaning there's no fixed point, right? For actually 0 fixed point, meaning the number of derangements alone. Okay? So, we're going to look for a number of N, R, and K. So if we don't have fixed point, this would talk about the derangement itself, which means that all of the placements are required to be non-repeating in their specific placement. So we have here the result. Our K is 0. Again, we're taking 3 permutations, so our R here is a 3. Okay, unlike the previous video where for 3 objects, we have the 3 permutations of that. So here, let's solve first for 3 and then 0. How many permutations in N4 where there's no fixed point, and this corresponds to the derangements, okay? The derangements themselves. So let's try to input here. Our R is actually 3, combination 0, 4 minus 3 factorial, summation of -1 to I, 3 minus 0, combination I, 3 minus, that's 4, so our N is 4, 4 minus 0 minus I factorial. R starts from 0 through R, which is 3 minus 0. 3 minus, similar to that. That's one thing that you can actually check on. So we'll have here 3, combination 0. You will get 1 over 1 factorial. Okay, then you have the summation of -1 I. You have here 3 combination I, 4 minus I factorial. As I starts from 0 to 2. To 3 rather. 3 minus 0 is 3. Okay, so let's have it like this. Hopefully you can follow. I'm going to separate. This is actually just equal to 1, so that's okay. So we'll have the summation already, or 1 times the summation. So for -1, okay, you will have here raised to the power of, let's break the summation, power of 0, 3 combination 0, 4 minus 0 factorial, plus -1 raised to 1, 3 combination 1, and you will have here plus, it's not plus, times 4 minus 1 factorial, plus -1 squared, 3 combination 2, 4 minus 2 factorial. We are not yet done because we need to end at 3. So we have here plus -1 cube, 3 combination 3, 4 minus 3 factorial. These are all to be multiplied by 1, so you can simply have it as separate already. So that's 1. 3 combination 0 is again you can check it in your calculator. 3 combination 0 is 1. And you have here 4 factorial. Plus -1 to the power of 1 is -1. 3 combination 1 is 3 times 3 factorial. Plus +1, the square of -1. 3 combination 2 is actually 3 as well. Then you have 2 factorial. And plus -1, because that's the cube of -1, times your 3 combination 3 is just 1. You can check that again in your calculators, and you will have your 1 factorial. Okay, So by simplifying that, you will have 24 for 4 factorial minus 3 times 3 factorial, which is 6, plus 3 times 2 factorial, which is 2, minus 1. Right? This is 24 minus 18 plus 6 minus 1. So you have 24 minus 18 plus 6 minus 1. You will get a result of 11. This corresponds to the derangements already, because the derangement stands for 0 fixed point. And that's already the derangement for the specific 3 permutations on N4. Okay? But since this problem talks about different sets, by the way, you can list that on your own. I will be proceeding now to what if we will have specifically one fixed point. So what if k is equal to 1 fixed point. Hence, we have here d 4, 3, and 1. Okay? So this is actually, again, r, that's 3, combination 1 over 4 minus 3 factorial, summation of negative 1 raised to I, r minus k is actually 3 minus 1 combination I. You have 4, the formula here, 4 minus 1 minus I factorial, where I starts from 0 to r minus k, 3 minus 1. So we can break this. Again, I might be using a separate page for this. So 3 combination 1 is again 3 over 1 factorial times the summation of negative 1 power of I, 2 combination I, 3 minus I factorial. I starts from 0 to 2. So we only have until 2 for our expansion. This obviously 3. You can separate that. Negative 1 raised to 0 plus, times 2 combination 0, 3 minus 0 factorial, plus negative 1 to the power of 1, 2 combination 1, 3 minus 1 factorial, plus negative 1 squared, 2 combination 2, 3 minus 2 factorial. We end up at 2 because that's our upper bound here. But that's actually 3 times, can we do this now automatically? That's 1 times 1 times 3 factorial. Okay? So minus 1, 2 combination 1 is actually equal to 2. So 2 times 2 factorial. Okay? Because 2 combination 0 earlier in the first term is equal to 1. Then you have plus, this is positive 1, that's 1. So you have 1 factorial here, which will give us a 3 times 6 minus 2 times 2 is 4 plus 1. That's 3 times 3. You'll have 9. 9 permutations. These are not derangements because we have a fixed point. But to answer, 9 permutations of with 1 fixed point. Okay? So they are different. These are derangements, but these are permutations with 1 fixed point. Now let me use another page, because we can also talk about what if in the permutation of 3, two placements are fixed, or 2 fixed points. We have 2 fixed points, and we also have what if all of those points are fixed. So let me add here another page. Let's have here if our k is equal to 2. So we have d n r k. Again, our n was 4. Our r is 3 permutations for 4. This is actually equal to d of 4, 3, 2. We have r. The formula is here. Okay, you can check that later. 3 combination 2 for your k. 4 minus 3 factorial. Summation of negative 1 raised to I. R minus k is 3 minus 2 combination I. Then 4 minus r, which is 2 minus I factorial, where I starts from 1 to 3 minus 2, your r minus k. 3 combination 2 is again 3 over 1 factorial. So you have here, summation of negative 1 raised to I. That's 1 combination I. 2 minus I factorial, where I starts from 0 to 1, because that's our r minus k. So by expansion, this is again 3 negative 1 raised to 0, 1 combination 0, 2 minus 0 factorial, plus negative 1 raised to 1, and we end up here because our upper bound is 1, so you will have 1 combination 1 and 2 minus 1 factorial. So we can see here, this is just 3 times, that's 1, this is also 1, that's 1 factorial, minus, 2 factorial rather, my bad, that's 2 factorial, minus, you have here 1 factorial. This is actually 3 times 2 minus 1, 3 times 1, only have 3 permutations with 2 fixed points for this situation. And finally, what if k is 3, meaning all of the points in the 3 permutations of n4 are fixed? So you have d of n r k stands for d of 4, 3, 3. This is given to us by 3 combination 3, that's r combination k. 4 minus 3 factorial, summation of negative 1 raised to I, r minus k, so 3 minus 3 combination I, okay, and you have here 4 minus 3 minus I factorial, where I starts from 0 to our 3 minus 3, which is 0 as well. Okay, so that's actually 3 combination 3 is actually 1 over 1 factorial. Okay, so we have that times the expansion of this. Take note, if you have 0 combination 0, that's actually equal to what I'm talking about. This one here, 0, because this is again 0, okay? 3 minus 3 is 0. Okay, let me write the steps that you will be guided if you're asking for them. Summation of negative 1, sorry, that's 1, power of I, that's 0 combination I, 1 minus I factorial, I starts from 0 to 0, okay? Again, that's 1 times, for the expansion until 0 alone, negative 1 raised to 0, 0 combination 0, 1 minus 0 factorial, which gives us 1 times 1 times 1 times 1 factorial, which is also equal to 1, so 1. This tells us there's only one permutation, one 3 permutation of n4 for this specific situation. So we have shown you here the different sets of permutations for the 3 permutations of n4, considering that there are some derangements to be removed as well. So the first one, as mentioned, when r is equal to 0, that's your derangement, because that entails no fixed points. So that's your derangement, connected to the previous lesson, which is on the derangement. And then we have this as we count the number of permutations, and at the next page as well, when we have fixed points. Okay, so this is still part of the counting techniques and even the combinatorics, because we're talking about number of arrangements considering fixed point, and that's the concept why we include this in the principle of inclusion and exclusion. We exclude those items with fixed point. Thank you very much for watching.